This video is for lesson 7-1 about parallel lines and angle relationships. It's the first video for activity 7, which is about parallel lines and perpendicular lines. Learning goals are to make conjectures about the angles formed by a pair of parallel lines when they're crossed by a transversal line. And we'll also prove some theorems about these angles. The scenario that we're going to investigate in activity 7 has to do with a company that lays bricks on a patio. Here's a picture of a patio and you see the brick pattern. Matt works for a company called Patios by Madeline. A new customer has asked him to design a patio and walkway. The rows of bricks in the patio will be parallel to the walkway as shown. So far, Matt has used stakes to tie down two parallel strings that he can use to align the rows of bricks. He also uses paint to mark an underground gas line to the house so he can avoid accidents. The string lines and the gas line intersect to form 8 angles. So let me show you a picture of what that's talking about. So here's the same thing we were just looking at, but without the brick pattern kind of disguising things. There is a walkway over here. And the bricks we want to be parallel to that walkway. We want them to run in the same direction as the walkway. So they have pounded a stake in here, and then connected with a string. That's called a string line. And then over here done the same thing. This string line is parallel to this one. It's actually a symbol that you can draw on two lines to show that they're parallel. It's a little arrow symbol. If they both have the same style arrow, that means the lines are parallel. Now underground there's a gas line buried, and that is shown here with this vertical gray line. Apparently the company painted that so they can avoid hitting that when they're doing their work. Notice how that gray line is crossing both string lines, and at each point of intersection 4 angles are created, and they're numbered 1, 2, 3, 4. And then over here at this string line the 4 angles are numbered 5, 6, 7, and 8. So here is a geometric drawing of this situation. Now we're asked several questions about that drawing. First, use a protractor to measure each of the angles formed and record those measurements. Instead of recording them here, I'm going to record them back on that drawing. And here are the measurements in green ink. On a protractor, angle 1 measures 115 degrees, while angle 2 measures 65 degrees. Angle 3 is 115, angle 4 is 65. Down at the other intersection point, we have similar measurements, some 115 degree angles and some 65 degree angles. The entire main idea of this lesson is that when you have parallel lines and they are crossed by a transversal creating 8 angles, that some of those angles will be congruent to each other and some of the angles will be supplementary to each other. Focus your attention on this top intersection point where angles 1, 2, 3, and 4 are located. Angle 1 and angle 3 are congruent because they're vertical angles. 2 and 4 are congruent to each other because they're vertical angles. 1 and 2 are supplementary. They're sitting side by side and they create a straight line. They must add to 180. As you look around in other places, you'll see some supplementary angles. These are all relationships that we've already studied earlier this year, that vertical angles are congruent and that sometimes angles are supplementary. But when we have parallel lines and we're looking at 8 angles, we can look for more relationships. For example, notice that angle 1, which is 115, is congruent to angle 5, which is 115. These are not vertical to each other nor adjacent. In fact, they're not even next to each other at all. Each of them is located at a different parallel line. But there is something that we could say about their relationship. We can call them corresponding angles. They're in the same relative positions around their point of intersection. Here's what I mean by that. If you focus at the top where the 4 angles are up here, we might describe angle 1 as being the top left angle out of the 4 angles. And down at the other point of intersection, angle 5 is the top left angle out of those 4 angles. They're in the same relative positions. The word for that is corresponding. What angle corresponds to angle 2? Well, angle 2 we might describe as being the top right angle of those 4. So down here, which is the top right angle of these 4? Well, that would be angle 6. Notice that they are both 65 degrees. So this makes us conjecture that corresponding angles are congruent. There are some other relationships in here that we could describe as far as where angles are positioned to each other. Take a look at angle 4, which is 65 degrees. Down here at the other intersection point, take a look at angle 5 right here, which is 115. 65 and 115 add to 180. They are supplementary. How could we describe the relative positions of 4 and 5? Well, they're not corresponding. One thing I notice is that they are in between the parallel lines. We could say that they're in the interior of the parallel lines. Another thing I notice is that they're both on the same side of this transversal line that I'm highlighting in green. They are same side interior angles, and they are supplementary. Let's go over on the other side of the transversal line. Angle 3 and angle 6, 115 and 65 degrees adds up to 180. Those are supplementary. These are same side interior angles. They're interior because they're between the parallel lines, and they are on the same side of the transversal as each other. So again, this leads us to this conjecture. Same side interior angles are supplementary. In this lesson, we're going to have some vocabulary words such as corresponding angles, same side interior angles, and we want to make some theorems describing the relationships of those angles. For example, are they congruent to each other? Are they supplementary to each other? Or what's going on? Here in question 3, you see some conjectures involving some vocabulary words. Corresponding angles are congruent. We just looked at some examples of that. Same side interior angles are supplementary. We had some examples of that. And there's one additional vocabulary word we didn't yet talk about. What if we are looking at the interior angles, so the ones between the parallel lines, but on alternate sides of the transversal line? We could conclude that those are congruent. If these are parallel lines and some transversal crosses through, that angle and that angle are on alternate sides of that transversal, and they look congruent. Number 6, the corresponding angles postulate involves angles formed by parallel lines cut by a transversal. Based on our earlier conjecture, write this postulate in if-then form. If parallel lines are crossed by a transversal, then corresponding angles are congruent. I'm going to pause the video for you to add that to your note page. You can add it to the line paper where you're putting today's work, but the more important thing is you add it to that permanent note page that you're keeping all year long. That way you can use this for the rest of the year. Question B, do we need to prove that this postulate is true? And the answer is no. Because this is a postulate is a statement in geometry that is accepted without having to prove it. In number 7, we're asked to write the other two conjectures that we made using if-then form. So we have if parallel lines are crossed by a transversal, then alternate interior angles are congruent. And our other one, if parallel lines are crossed by a transversal, then same side interior angles are supplementary. I'm going to pause the video. Please add both of these theorems to your notes page that you're going to use the rest of the year. Here are some check your understanding questions. I'll pause the video for you to answer these. And here are the answers. Number 8, explain how you know that angle 4 and angle 6 are same side interior angles. Here's angle 4, and right here is angle 6. They are between lines L and M, and they are both to the left of the transversal. Number 9, are angle 2 and angle 3 corresponding angles? Here's angle 2, here's angle 3. These are not corresponding angles, they are adjacent angles. The one that does correspond to angle 2 is located at the other intersection point. It would be angle 5. Number 10, if angle 5 is 65 degrees, then what's the measure of angle 4? So we need the relationship between angle 5 and angle 4. These are called alternate interior angles, and there's a theorem about that. Alternate interior angles are congruent, and so the answer is 65 degrees. Next, number 11. We're told that we have two angles that are corresponding angles. Because they are corresponding angles, they are congruent. And that's how I can make an equation. I say that they're equal to each other. Subtract x from both sides, subtract 6 from both sides, we get 2x equals 18. Therefore, x equals 9. If we want to find angle BCD, we substitute 9 into the formula given for BCD. That was the one with 3x plus 6. So 3 times 9 plus 6 is 33 degrees. How did we get our answers? We used the corresponding angles postulate, which is why we knew to make them equal to each other. Finally, let's prove one of those two theorems we created today. So let's say we have our typical drawing of parallel lines with the 8 numbered angles. We're told that M and N are parallel. So if we want to prove that angle 4 and angle 5 are supplementary, the proof could look like this. First, write down that M and N are parallel. The reason for writing that is that was given to us. Next, let's say that angle 1 is congruent to angle 5. In the drawing, that's this angle and this angle. We want to say they're congruent. Why can we do that? Well, they're corresponding angles. So we can use the corresponding angles postulate to know that they are congruent. If angle 1 is congruent to angle 5, we can logically conclude that the measure of angle 1 equals the measure of angle 5. That is the definition of congruent angles. That is written on your note page that I hope that you're using all year long whenever you're asked for reasons in a proof. Next step, let's say that the measure of angle 1 plus the measure of angle 4 is equal to 180. Where does that come from? Well, look up in the drawing. Angle 1 and angle 4 are side by side. They're creating this straight line. They're supplementary, and that means that their angles will add to 180. So this is the definition of supplementary angles. Two angles that sit side by side and make a straight line, the measures are going to add up to 180. How come angle 5 plus angle 4 equals 180? Well, what's going on here is we're taking the equation that we just had and we're replacing the measure of angle 5 in place of where it has the measure of angle 1. And that creates angle 5 plus angle 4 equals 180. That is called substitution. Finally, if we have these two measurements and it equals to 180, then what we can conclude is that angle 5 and angle 4 are supplementary. Once again, that was the definition of supplementary angles. We had used that earlier to kind of work this situation in reverse. In this lesson, we talked about 8 angles that are created from parallel lines being crossed by a transversal and introduced some new vocabulary about those angles regarding their positions relative to each other. For example, the word corresponding, alternate interior, or same side interior. And we created some theorems about those angles to indicate whether they were congruent or supplementary.